configuration, referring to how those repeating units contribute to the properties of polymers by having elements attached, different elements attached to give polymers different properties. So it is possible that you can have a variety of these repeating units that is defined as polymer configuration, which contributes to properties. So the simplest or the basic type of polymer will be polyethylene. It is the simplest because it is made up of 2 carbons and 4 hydrogens. So the basic backbone or the basic structure of polymers, all polymers, they have a backbone of carbon joined to carbon, indicated by black there. All polymers have that basic structure, carbon connected to carbon, and then to those carbons on the sides, which is what are called side groups, you have hydrogens attached. So the basic one of them is the 2 carbons and 4 hydrogen highlighted here, and this is what you call the repeating units, the mer. And then the other term is called a monomer, mono meaning one. So you have this connected to another monomer and another one, that gives you a polymer. Each repeating unit is called a monomer or a mer. So the typical examples of polyethylene would be this in the bottle industry, and we are familiar with that. So what happens then to get different properties to this basic structure? We have hydrogens highlighted in red, one of them indicating the possibility of attaching a different element there to give different properties. Let's look at that in a bit more detail. So if you replace one hydrogen with chlorine, you get polyvinyl chloride. That would be a monomer or the mer. So this next to another one continues as a chain. The only difference being you replaced one hydrogen with chlorine there. That changes the polymer completely, and you get a different polymer, which is polyvinyl chloride. The same thing happens if you replace one hydrogen with a CH3, which is 1 carbon and 3 hydrogens, written in short like that, CH3. Again, that gives a different polymer, which is a polypropylene in this case. Similarly, if you replace one hydrogen with fluorine, you get Teflon or polytetrafluoroethylene. Totally different polymer with different properties. Then this continues as a chain, next to a chain. That's what makes up a polymer, and they are all different in terms of properties. So this is what happens in the manufacture of polymers. All they do is to add different chemicals or elements that are attached onto the main chain. So to recap, all polymers have the same backbone of carbon joined to carbon. That's the backbone of all polymers. What makes polymers different is what is attached as a side group, replacing one hydrogen with different elements to give different polymers. In terms of the variety that you get, you can have those repeating units as the same kind throughout the chains, and that will be called a homopolymer. Homo meaning one or the same kind, hence one type of monomer or mer. So definition, homopolymer consists of only one type of repeating unit, same throughout, like A. But there's a possibility of having a variety in that you can have a contribution in terms of properties from 2 different monomers. So that will give a copolymer, which is a polymer that consists of more than one type of repeating units, two, or more than one. So that's the difference between homopolymer and a copolymer. So let's look at the copolymers in a bit more detail. So there are only 4 types of copolymers that you can find, which will determine properties as well. You get random arrangement, like A, B, B, A, A, B, A, B, A, B, 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 like in a random fashion. That will be a random copolymer. Notice that it's not a random polymer, it's a random copolymer because it's made up of more than one. If the arrangement is alternating, the name will be alternating copolymer. If you have the arrangement with a stretch of one type joined to a stretch of another in a block version, that would be called a block copolymer. You can also have craft or branched copolymer, which can be done in different ways. You can have one type of monomers attached to each other and a different one attached to that as a branch, or even all the A's and then branching as all A's. It would be a branched one. So these are the 4 types of copolymers that you have to remember. So just showing them in a different way: random, alternating, block, and a craft. So you get different properties depending on the nature of the monomers or their distribution. So in 2 ways: what is attached in what order and how they are distributed on the chain. So in terms of applications, like common applications, the random arrangement, they make up the common polymers that we know as rubbers. Technical terms: styrene butadiene rubber or ethylene propylene rubber. So generally, random arrangement, they will give you rubber type of polymers. And then the other one, alternating arrangement, will give the maleic anhydride, will give you polyamides and the rest of them. And then the blocky one will be styrene butadiene styrene, and this is the one that you usually use for 3D printing commonly, acrylobutadiene styrene. This will be the branched one. So again, just indicating that different copolymers will give different polymers which have different properties because of the arrangement of the monomers, the repeating units.